solving rational equations using the LCD method, that's lowest common denominator. So to use the LCD method, off on the side, let's go ahead and build an LCD. Our goal is to make all of the denominators that we see cancel. So when we see an x plus 1 in a denominator, we want to have an x plus 1 in our LCD. You'll see when we go through the process how that will cancel. Here we have a 2x. We want to see a 2x. That's represented in the LCD. And then this x over here actually will get canceled by that x right there. So we are set. This is our lowest common denominator. If it helps us to see this as over 1, that might help us to remember when we multiply. This next step I'm going to show you how this works. So we have our LCD. We're going to multiply every single term in our problem by that LCD. So we're going to do our 2x times x plus 1 over 1. So that over 1 just helps us remember that we are multiplying in the numerators. Even though we're calling it's an LCD, lowest common denominator, it does get multiplied up here in the numerator. So 2x times x plus 1 over 1, and then 2x times x plus 1 over 1. So every single term, both sides of the equal sign, get multiplied by our LCD. So now, when we simplify this, here's the reason why we did this whole thing. In this first term, we see an x plus 1 up here in the top and an x plus 1 in the denominator, and those will cancel, leaving us with a 2x times a 3x. Plus, in this next term, our 2x and our 2x will cancel, and it leaves us with a 6 times x plus 1 equals, this x in the denominator is going to cancel with that x next to the 2, so it leaves us with 7 times 2 times x plus 1. So we have no fractions left. That was our whole goal. So right now we're just going to do multiplying, distributing, just get everything all laid out so we can start solving for x. So 2 times 3 is 6, x times x is x squared, plus let's distribute the 6 and get 6x plus 6 equals, now this 7 times 2, since they're both on the outside, we can go ahead and say it's 14 times the x plus 1, and then distribute that to get 14x plus 14. Now anytime that we have a term with x squared and a term with x, we are going to solve by factoring. So let's get everything together, set it equal to 0. So if we subtract 14x from both sides, and then I'll just go ahead and subtract 14 in the same step. So those are going to cancel, and we have 6x squared. Now 6x minus 14x is a negative 8x, and 6 minus 14 is a negative 8 equals 0. Now we may notice as we go to factor this that we can actually factor a 2 out of each term. This will just leave us smaller numbers to work with, which will be nice in our factoring. So to factor, we have a number in front of the x squared, so we're going to do 3 times negative 4, and we get a negative 12. Factors of negative 12 that add up to a negative 4, and we're coming up with a negative 6, positive 2. So over here I'm going to rewrite our factoring. First term stays the same, 3x squared minus 6x plus 2x minus 4 equals 0. We're rewriting that middle term. Now it's factor by grouping. Factor out a 3x, we're left with x minus 1. Plus, we can factor out a 2, and we're left with x minus 1. And so factored form, we have that 3x plus 2, and the x minus 1 equals 0. Now we did factor a 2 out in the beginning, so we always want to remember to keep all of our factors together. Now solving for x, anywhere that we see an x is where we actually write those mini equations. So 3x plus 2 equals 0, and x minus 1 equals 0. So solving for x, subtract 2, divide by 3. Here x is equal to a negative 3 halves. And then add 1 to both sides. Here x equals a 1. So these are our two solutions. But really, are they our two solutions? This is where we would go back to the original problem, plug them in. I'm actually running out of time. I don't have time to do this right now. But we would want to plug those in and see if they worked out. You could do a quick denominator check. You know, if you were to plug these in to the x's, you know, right here, or possibly right there and right there, would we get that 0 in the denominator right away? If so, you can cancel that one off. But right now, we'd have to plug those both in, simplify, see if they are true solutions. So just know, look for extraneous solutions, and if they both work out, we have two solutions.